So in this video, we're going to be taking a look how to convert into y equals mx plus b. So depending on the format the data comes in, we're going to determine what we're going to do. So we're going to be taking a look at 4 different instances on converting to y equals mx plus b. All right, you need 2 things in order to use this format. We need the slope and we need the y-intercept. We need the slope and we need the y-intercept. So the first mode that we're going to take a look at is when we are in graph mode. All right, so we are in graph mode. I have a handy dandy graph for us here. And so the question is, how can I make this graph an equation? All right, so when we are in graph mode, we first need to grab the y-intercept. All right, so we need to grab the y-intercept. And the y-intercept is where I cross the y-axis. Right? So in this case, remember, the y-axis is my vertical line. So I cross my y-axis right here at this spot, which is where y is 1, 2, 3. All right, so y in this case equals positive 3. Okay. The second step that I need to do is I need to find the slope. And I'm going to find the slope in this case by counting squares. And remember, we do rise over run. Okay, so in this case, I do have 2 points illustrated, or I can now put this third point of my intercept. And I need to figure out, how do I get from one point to the next? So in this case, I am going to go down 2 and 1, 2, 3 right. So rise is my up down. So we went down 2. We went right 3. So this would convert to down 2, right 3. And then once I have those 2 pieces of information, I'm now going to go ahead and write it into the format. Y equals, this is my m, so negative 2/3 x, and this is my b, and it crossed at positive 3. So we took this line, this graph, and we made it into our equation. Okay, so let's do this again. All right, first step, I need to see, where do I cross my axis? So I scan my line. All right, so what do you think my axis is going to be? Okay, so we're crossing right here. All right, so my b, my y-intercept, equals negative 2. All right, I need to now get my slope. How do I get from one place to another? So remember, it is rise over run. So how do I get from one point to the next? All right, so I go 1, 2, 3 up, 1, 2 right, rise is my 3 up, run is my 2 right, up is positive, right is positive, line is positive. And so now I have to write my equation, which would then result in being y equals 3 halves x minus 2. I stole my m and I stole my b. Okay. So that's what we do when we are in graph form. Where do I cross the axes? And then I have to find the slope by counting squares. Okay. Another format that I might have to use is when I am in table mode. So right here, I have 3 different tables. And the reason why I have 3 different tables is because in step 2, finding my y-intercept, I actually have 3 different ways that I'm going to find it. And it's all going to depend on my table. Okay, so let's take a look at these. So first thing I need to do is I need to find the slope. Okay, so remember in table mode, we find the slope by finding the rate of change, which is doing the loop-d's. So we find our change in y over change in x. All right, so my loop d1 here, I'm increasing 2. My loop d here, I am decreasing 6. Because I'm going from positive to negative, that is a decrease of 6. So that is negative 6 over 2, which equals negative 3. All right, I need to check my next loop-d just to make sure my data matches. All right, so here we have a decrease of 3. And here I'm adding 1, which is negative 3 over 1, which is in fact still negative 3. So in this case, my slope is negative 3 over 1. Okay, so now we're going to find the y-intercept. Okay, so to determine the y-intercept, it's when x equals 0. All right, so my first thing that I should always look for is, does 0 exist in my table for x already? Does it exist for x already? And in this case, there is a 0. So because there is this 0 already in my table, I can steal it. Because if I were to graph 0, 4, I would be at the y-intercept of positive 4. So there is no extra math that needs to take place. In this case, my y-intercept is the number 4. I steal it right from the table. Once I have those two pieces of information, I go ahead and I write the equation that would go to this. Y equals negative 3x plus 4. Okay, so that is steal from table. So that's my instance if I can steal right from the table and do what I need to do. All right, so now let's take a look at another table. So we have 4, 7, 8, negative 18, negative 24, negative 26. All right, we're still doing the first step of finding the slope by doing the loop-d's. All right, so I loop d here, I get a plus 3. I loop d here. Now, if you're going, I'm not exactly sure how I do that. We're going to turn our calculator on, and we're going to type in negative 24 minus negative 18, because I want to know how did I get from this one to the next. And in this case, I subtracted 6. I decreased 6 more. Okay, so we have negative 6 over positive 3, which equals negative 2. Again, we're going to check the next loop-d just to double check it. So how do I get from negative 24? We subtract 2, and this is a plus 1. All right, so again, negative 2 over 1 equals negative 2. So my m has to be negative 2. Okay, so a second strategy, aside from stealing from the table, because in this case I don't have my 0, is to loop d backwards. And I'm going to loop d back to where x equals 0. Okay, some people like to make a new table. Other people just kind of like to write a 0 next to the x. And then I want to figure out, what does y have to equal? So I have to loop d backwards. What I'm going to do is I'm going to use my consistent numbers to do this loop d-ing. Okay, or I can use my 2 over 1. So here, I know for every loop d of 1, I have to loop d negative 2. So every time I loop d negative 1, I have to loop d positive 2. I could also loop d backwards 3, which means I'm going positive 6. So I'm kind of doing the opposites of these. Okay, so I need to go from 4 to 0. Okay, so what that means is I have to loop d backwards 4. I have to subtract 4. 4 minus 4. Well, notice here, 3 and 1 made 4. Well, when I moved forward 4, that means I moved minus 8, which means I have to go plus 8. I have to do the opposite. So that means my data started at negative 10. Okay. Now, some of you guys look at that and you went, what in the world just happened? That's okay. That is going to happen. And if that's the case, this might not be the choice for you, or you might only choose it when it's a little bit more obvious. But again, we have to loop D backwards because my y-intercept is when x equals 0. Okay. My last method that I can do, I'm going to show here. So again, we still got to do our loop Ds. So here I added 4, and here I added 2. So we have 2 over 4 equals 1/2. All right, we're now going to loop D again. 14 to 16 was plus 2. We have plus 1, and we still have our half. So in this case, m is 1/2. Okay, so my second strategy would be to use the format, or I should say third format, y equals mx plus b. Okay, and what I'm going to do is I'm going to steal my data. I'm going to circle a coordinate, and I'm going to circle my m, and I'm going to use those two pieces of information, and I'm going to plug them right in here. So y is the number 8 stolen from my table. M is a half stolen from what we just did. X is the number 10 stolen from my table, and I don't know B. 8 equals, well, half of 10 would be 5 plus B, and I would subtract 5 from both sides, so B would equal 3. Okay, so in this case, then, I have my M and I have my B, which means y equals 1/2 x plus 3. So right here we have 3 different methods I can solve to find my y-intercept. I can steal from the table if my table has x equals 0. I can loop D backwards to where I can make x equaling 0. Or I can use the equation and plug in 1 point and my slope. Okay? The third way that they can give me information would be in word problem form. So I have this example here, Sally putting $100 into her savings account she got for her birthday. She deposits $5 each week to save up for a new TV. All right, so there's no actual steps for this one. We have to understand a couple of vocabulary words. Every time I see the word each, that is typically my slope. So typically, whenever I see the word each or every, that is my slope. Okay? When I have money that is a one-time thing, that is my y-intercept. So the equation for the story then that we're telling is that my answer of weeks or amount of money is going to be when I deposit $5 every week, or I can use an X there if I want, plus the $100 that I start off with. That's as straightforward as it gets with the word problem. All right, so here's another word problem for you. You can try this one. The 8th grade class wants to sell snow cones at the upcoming dance. They spent $120 on materials, and they want to sell them for $2 each. So let's create an equation of how many snow cones I would need to sell, or how many snow cones would make me how much money. So go ahead and pause this video and write an equation yourself and see what you can come up with. All right, keep pausing if you need to, but notice we have the word each, and here we have a one-time fee. All right, so we should have had y equals, I'm selling them for $2 each, and I spent $120. So I was in the negative to start. That's important because as I'm making money, I have to cancel out from this 120 before I would see anything positive. Okay? Then last but not least, we have in the case of converting equation mode. And I have to be into this format where y is by itself. So I have 3 different instances here where y isn't by itself. Okay, so we're going to take a look at what we do here. So here I need to isolate y, and negative 2x is in the way. Okay, so we're still going to do opposite operations. So opposite of negative 2x is positive 2x. What I do to one side, I have to do to the other. Therefore, this cancels. So y is going to equal, these two cannot combine because this is x and this is a constant, and I want mx plus b, so I'm going to rewrite it as 2x plus 17. What you're going to notice with this is anything that I send from one side to the other is going to become the opposite operation, okay? Which is going to be true here in B. Right now, y is negative. He's negative. I want him positive. So keeping in mind with our rule, anything I send to the other side of the equal sign will turn to the opposite. So I want a red rover, send that negative y over, because when he goes to the other side, he's going to become positive. So when I send him to the other side, I get 1/4 x equals 2 plus y. Again, if I add y to both sides. Now the 2 is in the way, so red rover, he's got to be sent over. He was positive on the right. He's now going to become negative on the left. So y equals 1/4 x minus 2. So again, we're just switching their places. The last instance that you might run into is in the case that there's something with the y. So we still need him by himself. All right, so the 8x is in the way. Red rover, send the 8x over. So we would get 2y equals negative 8x, because remember when we send him over, he has to switch to his alter ego, plus 10. And now I'm going to use the opposite operation here, and I have to divide all of these instances by 2 so that I get y equals negative 4x plus 5. Okay, so those are the 4 different formats to convert into y equals mx plus b.